Good afternoon, students. After this holidays, we can meet this chemistry online class. See, already we have learned the topic thermodynamics. There we learned first law of thermodynamics. Already this first law of thermodynamics we learnt. Now we can see the topic second law of thermodynamics. So here we are going to learn about the topic second law of thermodynamics. First law of thermodynamics we learned already. You know, first law means energy of the universe is constant. Already in the first law we learned energy of the universe is constant. Energy of the universe is constant. Just we can say some example. One simple example, you take a glass of hot water. You take a glass of hot water. You take some hot water in the glass. Take a glass of hot water. Just to see after some time. If you are seeing after half an hour, this water becomes cold. Reason, this one loses its heat energy. This hot water loses the heat energy and becomes cold. So listen, one simple example, you take a glass of hot water. This one loses its heat energy. After sometimes if you are seeing this hot water, this one loses its heat energy and becomes cold. This is the first example. Energy of the system is constant. Energy of the system is constant. So one of the simple example, you take a glass of hot water. After sometimes if you are seeing this hot water, this one loses its heat energy and becomes cold condition. This one becomes cold. Then second example, one more example. You take hydrochloric acid and sodium hydroxide. Hydrochloric acid and sodium hydroxide. You take hydrochloric acid and sodium hydroxide. These two molecules mix to form, you will get the product sodium chloride, NaCl, and hydrogen and OH together you will get H2O. So hydrochloric acid and sodium hydroxide mix to form sodium chloride and water molecule with the evaluation of heat. This molecules loses its heat energy and you will get the product sodium chloride. Understand? So two examples we learned. Tell the first example. Take a glass of hot water. This one loses its heat energy and becomes cold. Then second example. This two example. Hydrochloric acid and sodium hydroxide. Here this molecules loses the heat energy and you will get the product sodium chloride. Understand? Okay, listen. In both of these two process, energy of the universe is constant. In this two process, energy of the universe is constant. Energy of the universe is constant. See, listen, in the first process we learnt, first we taken hot water, this one loses its heat energy and becomes cold. First we taken hot water, isn't it? How we will get this hot water? You know already, if you are applying heat means only you can produce hot water. So listen. Heat energy is supplied to cold water. First we taken cold water. Here if you are applying heat energy is supplied to cold water, it becomes hot. Heat energy is supplied to cold water, it becomes hot. This changes does not take place in their own way. This changes does not take place in their own way. If you are applying heat energy only, you can change this cold water into hot water. Understand? This process does not take place in their own way. If you are applying heat energy, you can convert cold water into hot water. Same way, in this example, the second example, hydrochloric acid and sodium hydroxide to form sodium chloride. The sodium chloride directly this one does not absorb the heat energy. Directly this one does not produce hydrochloric acid and sodium hydroxide. By absorbing heat energy only, this two molecule loses the heat energy to form sodium chloride. So this sodium chloride absorb the heat energy to form hydrochloric acid and sodium hydroxide. See, here we are telling this statement, energy of the universe is constant. According to the first law, we are telling energy of the universe is constant. Just to see this two example. Understand this? Understand? See, listen one more time. According to the first law, we learnt energy of the universe is constant. Energy of the universe is constant. Here we can see two examples. First example, you take a glass of hot water. This one becomes cold. How it becomes cold means this one loses heat energy. And becomes cold. Here we are telling, first we taken hot water, isn't it? How we got this hot water means from the cold water. This cold water absorb the heat energy. To form hot water. So here we are telling energy of the universe is constant. The same way, second example, hydrochloric acid mixed with sodium hydroxide to form sodium chloride and water. Here the sodium chloride absorb the heat energy to form HCl and NaOH. So totally we are telling, according to the first law, energy of the universe is constant. Understand? Okay, listen. See, now we can see the next topic. Statements of second law of thermodynamics. What are the statements means? So listen, the first statement, entropy statement. Second law statement is entropy statement. Already entropy definition we learned. What is meant by entropy? Entropy means measure of the randomness or disorderness of the molecule. Entropy means measure the randomness or disorder of the molecule. The molecules are arranged in the random way or disorder way means we can find this. So entropy means measure the randomness or disorderness of the molecules. What is mean entropy? Entropy is a measurement of measure the randomness or disorderness of the molecules of a system. Understand? And already entropy definition you know. Entropy S or ds is equal to dq divided by T. Entropy ds is equal to dq divided by T. Here this entropy process is reversible process. So we are telling the formula ds is equal to dq reversible divided by T. That is the first statement. So first statement of second law is entropy statement. Tell the definition entropy. Entropy is a measure of the randomness or disorder of the molecules. You know the formula ds is equal to dq reversible divided by T. Understand? Now listen. The second law of thermodynamics we are telling entropy of an isolated system increases. Entropy of an isolated system increases during a spontaneous process. In the spontaneous process, we are telling entropy of a system increases. In the spontaneous process, we are telling entropy of an isolated system increases. So, we are telling entropy, total entropy value greater than 0. In the spontaneous process, this total entropy value increases. So, we are telling that is greater than 0. Greater than 0. Already total entropy formula you know. Delta S total is equal to delta S surrounding, delta S system plus delta S surrounding. Delta S total, delta S entropy total is equal to delta S system plus delta S surrounding. Here we learn this value is greater than 0. So we can write the formula delta S total greater than delta S system plus delta S surroundings. Understand? For a reversible process, already in the you know this topic, for a reversible process, delta S system is equal to minus delta S surroundings. For a reversible process, you know the formula, delta S system is equal to minus delta S surrounding. Just substitute this value here. If you are substituting, tell the formula, delta S total is equal to the system formula minus delta S surrounding greater delta S surrounding plus delta S surrounding minus plus, so you will get the answer delta S total is greater than 0. Understand? So listen. The first statement of second law is entropy statement. We know the definition entropy. Tell the definition entropy. Entropy is a measure of the randomness or disorder of the molecules. Entropy is a measure of the randomness or disorder of the molecules. We know the formula ds is equal to dq reversible divided by t. Then in the spontaneous process this value increases. So we are telling delta S total greater than 0. Already you know the formula delta S total is equal to sum of the system and surroundings. For a reversible process you know the system is equal to minus delta S surrounding. If you are substituting you will get the answer. This value becomes 0. Understand? So this is the first statement of second law of thermodynamics. Understand? Okay, see the second statement, Kelvin-Planck statement. Kelvin-Planck statement. The statement is, it is impossible to absorb heat energy. It is impossible to absorb heat energy from a source. It is impossible to absorb heat energy from a source and it convert completely to work. It is impossible to absorb heat from a source and it convert completely to work. It is impossible to convert heat to work. So Kelvin-Planck statement is, it is impossible to absorb heat from a source and it convert completely to work. And it convert completely to work. So tell the statement, Kelvin-Planck statement. It is impossible to absorb heat from a source and it convert completely to work. And it convert completely to work. Understand? Now listen. According to this statement we are telling 100% of input. 100% of input heat is converted to work. 100% of, see listen, according to this statement we are telling 100%, we cannot convert 100% input heat into work. 100% input heat, we cannot convert this input heat into work. Already statement, we learned the same statement only. Tell the statement. It is impossible to absorb heat from a source and it convert completely to work. Understand? Now listen. We are going to learn about the topic here, efficiency. You know the formula efficiency. Efficiency symbol eta. Efficiency symbol eta. Eta is equal to formula modulus Q height minus modulus QC modulus QH minus modulus QC divided by modulus QH. So tell the formula efficiency in this topic. In this statement, we are learning the topic efficiency. Efficiency eta is equal to QH minus QC divided by QH. Here we can take this like this. Eta is equal to QH divided by QH minus QC divided by QH. So we can cancel this 2 and you will get the answer 1 minus QC divided by QH. 1 minus QC divided by QH. Understand? Now listen. In the cyclic process, for a reversible process, already we learned the formula. Delta S universe or delta S total is equal to delta S system plus delta S surroundings. See, listen. First we learn the topic efficiency. Efficiency eta, we got the formula. Eta is equal to 1 minus QC divided by QH. Already for a reversible process we learned delta S total is equal to delta S system plus delta S surroundings. Understand this? Okay, see, listen. Eta formula we learned. Eta is equal to 1 minus QC divided by QH. 1 minus QC divided by QH. Here QC means heat transport. Here QC means that is heat transport to cold reservoir. This is heat transport. QH means that is heat absorbed. In this process we are telling QC means heat transport, QH means heat absorbed. Now we know the formula delta S total is equal to delta S system plus delta S surroundings. From this we can write the formula delta S. Delta S formula already you know, Q divided by T. Q divided by T. Here delta S system formula. Delta S system is equal to, system means that is absorbed, heat absorbed. So Q absorbed symbol H. So we can write QH divided by TH. We can write the formula QH divided by TH. Same way delta S surrounding formula, that is heat transport. So we can write the formula QC divided by TC. QC divided by TC. We know the formula delta S system is equal to minus delta S surroundings. Delta S system is equal to minus delta S surroundings. So tell the formula delta S system formula QH divided by TH is equal to minus QC divided by TC. Let's substitute this delta S system value and delta S surroundings value. Understand? See, listen. In this equation, take the temperature terms in one side and Q terms in another side. If you are taking, tell the answer. Take this TC this side and QH right side. So you will get the answer TC divided by TH is equal to minus QC divided by QH. Take this TC. So TC divided by TH is equal to minus QC divided by QH. Understand? Now take this modulus. If you are taking modulus, TC divided by TH is equal to, if you are taking modulus, you can write positive QC divided by QH. Understand? Now listen, already efficiency formula we learned. Efficiency eta is equal to 1 minus modulus of QC divided by QH. Modulus of QC divided by QH. Just consider this is efficiency equation is equation 1 and this is equation 2. Substitute this QC by QH value. This QC by QH value in this equation 1. If you are substituting, tell the answer. Eta is equal to 1 minus this QC by QH value TC divided by TH. So eta is equal to 1 minus TC by TH. In this equation, this TH value more greater than TC means, if this TH value more greater than TC means, you will get the answer. This eta value you will get less than 1. This eta value, suppose if this TH value more greater than TC means eta value less than 1. Eta value less than 1. The same way here you can write the formula percentage efficiency. See, this is efficiency formula. The same way we can write the formula percentage efficiency. Percentage efficiency means eta is equal to 1 minus TC by TH. 1 minus TC by TH into 100. Tell the formula percentage efficiency. Eta is equal to 1 minus TC by TH into 100. Understand? So this one only we are telling. Second statement, Kelvin-Planck statement. Can you tell the statement? Kelvin-Planck statement is, it is impossible to absorb heat energy. See, the second statement we learned, Kelvin-Planck statement. Kelvin-Planck statement means already we learned this one. It is impossible to absorb heat energy. It is impossible to absorb heat energy and it convert to work. It is impossible to absorb heat energy and it convert to work. And here we learn the efficiency formula. Efficiency eta is equal to 1 minus first we got the formula modulus of QC by QH. 1 minus modulus of QC by QH. There if you are applying system and surrounding, we got the formula eta is equal to 1 minus TC by TH. 1 minus TC by TH. And we can write the percentage efficiency formula. Percentage efficiency eta is equal to 1 minus TC by TH into 100. Understand? So this one only Kelvin-Planck statement. Understand this? So totally two statements we learned. First statement, entropy statement, and second one, Kelvin-Planck statement. Understand this? Listen. Now see the third statement, Clausius statement. Third statement, Clausius statement. Clausius statement means it is impossible to transfer heat energy. It is impossible to transfer heat energy. It is impossible to transfer heat from a cold body to heat body. Cold body to heat body. It is impossible to transfer heat. It is impossible to transfer heat from a cold body to hot body. From the hot body to cold body we can transfer, but from the cold body to hot body, that is impossible. So that only we are telling Clausius statement. It is impossible to transfer heat from a cold body to cold system to hot system. Understand? So this only we are telling Clausius statement. Understand? So listen totally. So statements of second law of thermodynamics means three statements we learn. What are the statements? First statement is entropy statement. The first statement, entropy statement. See in this statement, in the entropy statement we learned the definition. Entropy means measure the randomness or disorder of the molecules. Measure the randomness or disorder of the molecule. And here we learn delta S is equal to, we learn the formula delta S is equal to delta Q reversible divided by T. And here delta S total or universe is 0. That is constant or that value is 0. That is the first statement. Then second statement we learn Kelvin-Planck statement. Second statement, Kelvin-Planck statement. Kelvin-Planck statement means it is impossible to it is impossible to absorb heat, and this one is impossible to convert heat to work. It is impossible to convert heat to work. And here efficiency we learn, efficiency eta is equal to 1 minus Tc by T heights. 1 minus Tc by T heights, and percentage efficiency eta is equal to 1 minus Tc by T heights into 100. This is percentage efficiency. Understand? Then third statement. It is impossible to convert heat from cold body to cold reservoir to cold system to hot system. So this one only statements of second law of thermodynamics. This is one of the important 5-mark question. What are the statements we learn? 3 statements we learn. Entropy statement, Kelvin-Planck statement, and Clausius statement. Understand this? Any doubt? See, listen. Now take page number 209. Page number 209. Just note this topic. Need for the second law of thermodynamics. Need for the second law of thermodynamics. If your question, what are the need for the second law of thermodynamics means, note the answer. We know from the first law of thermodynamics, the energy of the universe is conserved. Let us consider the following process. These 2 processes, just to write, like 2 more questions, just to learn these 2 processes. A glass of hot water over time loses heat energy to the surrounding and becomes cold. That is the first example. Then second example, when you mix hydrochloric acid with the sodium hydroxide, it forms sodium chloride and water with the evaluation of heat. Just to note this 2 topic. Need for the second law of thermodynamics means just to note these 2 points. Understand? Okay. See, now take page number 210. This is important 5-mark question. Various statements of second law of thermodynamics. Explain the statements of second law of thermodynamics means this is first statement, entropy statement. The second law of thermodynamics introduces another state function called entropy. Then definition. Entropy is a measure of molecular disorder of or randomness of a system. And definition we are telling ds is equal to dq reversible divided by t. The statements, according to the statements we are telling that value increases during a spontaneous process. For an irreversible process such as spontaneous expansion of a gas, we are telling this value greater than 0. Delta S total value greater than 0. We know the formula delta S total is equal to delta S system plus surroundings. For a reversible process, the system is equal to minus surrounding. If you are applying this value, you will get the answer 0. Just to substitute the value, you can substitute delta S universe is equal to the system value only minus delta S surroundings plus delta S surroundings. So minus minus, so you will get the answer delta S universe is equal to 0. Understand? So this is the first statement. Then second statement, Kelvin-Planck statement. It is impossible to construct a machine that absorbs heat from a hot source and converts completely heat into work by a cyclic process without transferring a part of heat to cold sink. This is the statement. Till this is enough. Kelvin-Planck statement. Then note the point, efficiency. Efficiency formula. Page number 211. Efficiency is equal to work performed divided by heat absorbed. So note the formula, eta is equal to Q heights minus QC divided by Q heights. Understand? Then just write the explanation. Q heights means heat absorbed from the hot reservoir. QC means heat transferred to a cold reservoir. Then from there you can write, if you are writing this formula like this, Q's heights, modulus of Q heights divided by modulus of Q heights minus modulus of QC divided by modulus of Q heights means You can cancel this too. So you will get the answer 1 minus QC by QH. Understand? Then already for a reversible process we learn delta S universe is equal to delta S system plus delta S surroundings equal to 0. So from there we can write delta S system is equal to minus delta S surroundings. Just substitute the formula delta S system and delta S surroundings. Here delta S system is equal to QH divided by TH. The same way delta S surroundings equal to QC divided by TC. Just substitute this value. Then take temperature terms in one side and Q terms in another side. Then if you are taking modulus, you can cancel negative. So you got this answer. Substitute this value in this equation. So your answer 1 minus TC by TH. Understand? Then suppose here this TH value more greater means eta value less than 1. Eta value less than 1. Here you can write the efficiency formula. F is percentage efficiency formula. Eta in percentage is equal to 1 minus TC by TH into 100. 1 minus TC by TH into 100. Understand? Then third statement, Clausius statement. It is impossible to transfer heat from a cold reservoir to hot reservoir without doing some work. Just a note till this. This is important 5 mark question. Various statements of second law of thermodynamics. Page number 210. From the term entropy to page number 211 till this Clausius statement. Understand this topic? See now just we can see the topic. Unit entropy. Entropy unit. Entropy means entropy definition we learned already. Can you tell the definition entropy? Entropy is defined as entropy S is defined as heat energy exchanged. Heat energy exchanged divided by temperature. Heat energy exchanged divided by temperature. Heat energy exchanged is Q divided by temperature T. Understand? And we can tell the unit. SI unit of entropy is Joule per Kelvin. SI unit of entropy Joule per Kelvin. Understand? So listen. So entropy unit we learnt. SI unit of entropy Joule per Kelvin. SI unit of entropy Joule per Kelvin. Understand? Any doubt? Take page number 211. Just note the topic units of entropy. Entropy is equal to heat energy exchanged divided by the temperature at which exchange takes place. And this is the unit. SI unit of entropy Joule per Kelvin. Understand? See now take page number 225. Page number 225. Question number 45. Question number 45. State the various statements of second law of thermodynamics. State the various statements of second law of thermodynamics. Just note the statements. Page number 210. Page number 210. The statements fully. Entropy statement 2. Entropy statement. Kelvin Planck statement. Then page number 211. Clausius statement. Till this Clausius statement without doing some work. Understand? Then page number 224. Page number 224, question number 39. Give Kelvin statement of second law of thermodynamics. Give Kelvin statement of second law of thermodynamics. Page number 210. Kelvin statement, write this topic fully. Page number 210. From this too, it is impossible to construct a machine till this pulsing. Then page number 211. From this too, efficiency. This efficiency to till this eta value. Eta is less than 1. Suppose if it is 2 mark question, the statement only enough. If it is 3 mark question, just write the derivation also. Understand? Now note the next day's homework. This 2 question. Question number 39 and question number 45. Page number 224, question number 39 and page number 225, question number 45. Learn these two questions thoroughly. Understand? Okay, thank you.